Hello everybody. Alright, so today's lesson we're going to take a look at the distance between any 2 points on the coordinate plane. We've talked about the Pythagorean theorem. We've done some practice problems with that. And today this is going to be an application of the Pythagorean theorem. So, let's start. On a very, very basic level, if I'm looking at the distance between 2 points, and the points are lined up horizontally, like A and B, very, very easy. Likewise, if they're lined up vertically, like C and D, this should be really easy to find the distance between 2 points, right? If I look at A and B, all you have to do is count the units, right? They're in a straight line. So I have, let's see, 1 unit there, I got 1 unit there, 1 unit there, 1 unit there, which means I have a total of 4 units, right? I know what you're thinking. Hey, I graduated 2nd grade. I think I can count to 4. Awesome. I hope you can. So that should be 4. Nice and easy, right? All right. Vertically, same thing, right? I have 3 total units. I got 1 unit there, 1 unit there, 1 unit there. So I end up with a total distance of 3 units. Super easy, right? Okay. I hope so. So let's go to the next page. Let's take a look at a little more complicated. Not too much art. This is still not too bad, but a little bit trickier here. So we have some information. Paul is 3 blocks west and 1 block north of the Kodak building downtown, while Julie is 5 blocks east and 7 blocks north of it. And we want to know if Paul could walk along a straight line path directly to Julie, how many blocks would he need to walk? Find this to the nearest tenth of a block. So, Kodak building, one of the more cool looking buildings downtown. We've got a little picture of it down here. Now, both of these people are a few blocks away from the Kodak building, so since that is sort of our center of origin here, we're going to call that the origin, and we're going to put that right here at 0, 0. That's going to be our Kodak building. Okay, I'll even put a K there. Kodak. All right. Now, I want to find where Paul and Julie are. So Paul, we know, is 3 blocks west and 1 block north of the Kodak building downtown. So I start at the origin, and I count 3 blocks west, so I go 1, 2, 3 blocks west, and then we want to go 1 block north, so this is where Julie is. I'm sorry, that's Paul. So there's Paul. 2 blocks west of the Kodak building. I'm sorry, 3 blocks west and 1 block north. There's Paul. And I erase my K and bring my K back here. All right, there we go. So there's Paul. We got to find Julie now, right? Julie is 5 blocks east and 7 blocks north. So for Julie, we're going to go 5 blocks the other direction, 5 blocks east. And then we're going to go 7 blocks north. So we go over to 5 blocks, we go up 7, and here's Julie. She's 5 blocks east, 7 blocks north. And now what I want to find is the distance between these two. So assuming Paul could walk, apparently, through buildings, because there's buildings and things in the way, but either he's magical or maybe he's a ghost. Woo, ah. Maybe he's haunting Julie. I don't know. Anyway, so here's our line. We want to find this line. That's the distance I'm looking for. Okay? Now, last time I could count the units, right? Here I can't count units because it's at an angle. So that's going to make it a little trickier to find. But the basic idea, when I'm trying to find 2 points in a coordinate plane that are not horizontal or vertical, I want to find the horizontal distance between the 2 of them. I want to find the vertical distance between the 2 of them. And then I'm going to use Pythagorean theorem to find the length of the hypotenuse, which is what our distance is. So if I look at the horizontal distance here, I'll this is blue. Horizontal distance from Paul to Julie is right along this line here. And we can count those units up. It's 3 units from Paul to the y-axis, and then it's 5 units past that. So this ends up being a total of 8 units as a horizontal distance. And I want to look at the vertical distance, which I'll do in red here. The vertical distance from Julie to Paul is this distance here. And again, we can count those units. We've got a total of 6 units vertically. And the reason I care about those 2 is they form a right triangle. Here's our right angle. So given that, I now have 2 sides, in this case the legs, of my right triangle, and I want to find the hypotenuse. And as we saw the other day, our Pythagorean theorem is, say it with me, a squared plus b squared equals c squared. Awesome. So we're going to plug them in, right? A squared plus b squared equals c squared. So again, a and b doesn't matter which is which. I'm going to call the a 8. I'm going to call the 6 our b. So I'm going to plug these values in. 8 squared plus 6 squared equals c squared. And we're going to square both of those. 8 squared, of course, is 64. 6 squared, of course, is 36. Equals c squared. And we can add these two things together. 64 plus 36 will give us 100. Equals c squared. And now, of course, to find c, we square root both sides. The opposite of squaring is, of course, square rooting. So I square root both sides. We end up with c equals square root of 100, which would be 10. And again, normally plus or minus, but in this case, we're talking about a distance, so our positive value is good. So this would be 10 blocks for Paul to walk if he could walk through buildings. Okay, good so far? Questions? Never any questions. Interesting. Okay, so we're going to move on. Our next problem. So now we've got two random points, A and B, and we want to find the distance between points A and B. All right, so here's the time. Pause it. Try this problem on your own. I said pause it. Pause it. There you go. Okay, well, we'll assume you've unpaused now. You've done the problem on your own. If you haven't, shame on you. All right, so let's take a look. We want to graph these 2 points, right? We're going to graph 2, -5. That means I go over to the right 2 and down 5, right? That's going to be A. So 2, -5 is going to be right here. That is our point A. Now point B is 6, 5. So I go to the right 6 and up 5. So B is going to be right here. And now I want to find the distance between these two. So I'm looking for this distance right here. And again, it's at an angle, so I'm going to need to find my horizontal and vertical distances to make that right triangle. So here we go. Our horizontal distance, which I will do in blue, is going to be from here over here. That looks like that is a total of 4 units. We want to find our vertical distance. Vertical distance I'll do in red again. And that vertical distance is 5 between these two here, and then it's 5 more beyond that. So this ends up being a total of 10 units. And now, once again, I have the 2 legs of a right triangle, and I'm trying to find the hypotenuse, which we, of course, always call C. And again, A and B don't really matter. I will call A the 4, and I'll call B the 10, but it's up to you which one you want to call it. And we're plugging right into Pythagorean theorem. So 4 squared plus 10 squared equals our value c squared. We can square both of those, of course. 4 squared gives you 16. 10 squared gives us 100 equals c squared. We want to keep going. We want to add them together. We get 116 equals c squared. And of course, if I have c squared to get c, we always do the square root of both sides. There you go. So I get C. We turn to our handy-dandy calculators. I know 121 square root is 11, so it's close to that. Let's find out exactly what we get here. We square root 116, and we get 10.7703. So the nearest 10 is 10.8. And that should be our value for the distance between points A and B. Sound good? Questions? Okay. And that'll be all for today.